is given by. Okay, so here we are supposed to find the value of r. Let's try to understand this concept here. So there is, you can say, a convergence test which we can use here in order to solve this problem. So what is convergence test? Let me give you that test. So suppose R is, you can also call this as a ratio test or convergence test, ratio test or convergence test. Okay, where R is written as limit, in this case m tends to infinity, e m plus 1 divided by am. Okay, suppose this is the ratio. Okay, we are taking the ratio of m plus 1th term with am, mth term, as m tends to infinity, and depending on the value of r, suppose r is greater than 0, r is less than 0, or r is equal to 0, we can say whether the series will converge or diverge. So if r is greater than 0, the series will diverges. If it is less than 0, series will converge. If r is equal to 1, it may converge or diverge. In our case, it is specifically mentioned that series converges. So we should fall into the second category here. Okay, the problem is in second category. So with this, let's try to solve this. Okay, now limit m tends to infinity. M plus 1 will look like as m plus 1 whole square divided by s raised to the power, 3 raised to the power m plus 1. Yep. And x minus 2 raised to the power m plus 1 divided by m raised to the power 2 divided by 3 raised to the power m into x minus 2 raised to the power m. Yeah. So this is how it will look like. And now we will cancel out the terms here. So we can cancel 3 raised to the power m and 3 raised to the power m minus 1. Only 3 will remain there. Okay. Similarly, x minus 2 we can cancel out with. So I'll just cancel this m here. Okay, x minus 2 raised to the power m. X minus 2 will still remain in the numerator, and limit m tends to infinity. So here x minus 2 I can take outside the bracket because limit will not is not on the variable x. So x minus 2 I am taking outside. Limit m tends to infinity. Even 3 also you can take it out. Things which are in limit are only m plus 1 whole square divided by m square. Okay, and yeah, so these are the only things which are remain. So we can just focus on this part because our limit is only on m part. Okay, so let's simplify it further. M plus 1 whole square you can simplify as m square plus 1 plus 2m. So I'll just focus on the limit part. Limit m tends to infinity, m square plus 1 plus 2m divided by m square. Okay. If you individually divide it, you can cancel out, and limit limit m tends to infinity. M square will cancel. We got 1 here. Then 1 upon m square. If m is infinity, 1 upon infinity will be 0 plus 2 by m. Again, if m is infinity, 2 by 0. Sorry, 2 by infinity is 0. So again, you will get 0 here. So basically, we got 1 plus 0 plus 0, and we have x minus 2 here. And divided by 3 is there, right? So you can consider here now x minus 2 divided by 3 into 1, okay, is less than 1. Okay, hence you can say x minus 2 should be less than 3 in order to get the series to converge. Okay, hence here the option B is correct, that is r equal to 3. I hope it is clarified. I'm considering the case of r less than 1 because that is the only case where we will have definite convergence. Any doubt here? Coming towards next question. This is from the calculus topic about the differentiability, continuity. Okay, looking into the function, we got function in the form of sine when the value of x is not equal to 0, and for x equal to 0, the value of the function is 0. So if you look into the plot of this function, sine function I'm talking about, so it will look something like this: sine of 1 upon x. Okay, something lot of lines over each other are very, very close to each other, and like this, this function will look like. So what is so we know sine function is always bounded, or you can say always lying within the -1 to +1, irrespective of what angle we use or what is the value of x here. And so here from the given data, I can say f of 0 is 0. What about the value of the function which is very, very close to 0? So if I say limit x tends to 0 from the negative side or the positive side, then we cannot use 0 here. We have to use sine function, sine of 1 upon x. And basically, if you put 0, you'll get sine infinity. Sine infinity in the sense you'll get any value within +1 to -1, right? Because sine function is lying within the -1 to +1 band, so you will get any value in between -1 to +1, but that is not equal to 0. Okay, it can take any value. Hence, this function is not continuous everywhere. Okay, so left hand limit here, left hand limit is equal to the right hand limit, because we do have same criteria here, but that is not equal to the f of 0, you can say. Okay, or in short, limit x tends to 0, f of x is not equal to f of 0, and that is the reason we can say this function is not continuous at x equal to 0, though it is bounded. Hence, option C is correct in this case. Okay, f of 0 is 0 and limit x tends to 0, sine of 1 upon x will lie within -1 to +1. Hence they are unequal and we are giving it as not continuous. Coming towards next question. This is from the numerical methods, Simpson's rule formula. So here we have to solve integration I from 0 to 1 1000 x raised to the power 4 dx, and we have to obtain the solution of this by using Simpson's rule with the two equally spaced intervals. Whenever just Simpson's rule is mentioned, you have to assume it as Simpson's 1/3 rule. Okay, if it is specifically mentioned 3/8, in that case you can use 3/8 rule. But if nothing is mentioned, just Simpson's rule is mentioned, you have to assume it as a Simpson's 1/3 rule. So what is Simpson's 1/3 rule? Simpson's 1/3 rule is integration f of x dx from a to b is, you can say, h by 3 y naught plus yn plus 4 times y1 plus y3 plus y5 plus so on, okay, plus 2 times y2 plus y4 plus y6 plus so on. Okay, so we are differentiating it, or we are separating the even and odd values of the functions. Okay, so let's try to understand this through one simple table. So we have to break this interval 0 to 1 into two equally spaced intervals. So 0 to 0.5 and 0.5 to 1. So this is the value of x. For these values of x, we'll get the value of y. The initial value is x0, x1 and x2. x2 itself is xn here. Okay, that is nth value. As we are the interval here is 0 to 0.5 and then 0.5 to 1. So the value of h is here 0.5. Okay, h is equal to 0.5. The value of function f of x is equal to 1000 x raised to the power 4. F of 0 is 0. F of 0.5 is 1000 into 0.5 raised to the power 4. Or you can say 1000 into 1 by 2 raised to the power 4. You can write it as 1000 divided by 16. And f of 1 is 1000. Okay, so this is the y0 value, this is the y1 value, and this is the y2 value. Y2 is yn here. So now applying the Simpson's 1/3 rule, integral is equal to h by 3, h is 0.5, which means 1 by 2. 1 by 2 divided by 3 is 1 by 6. Y0 is 0, yn is 1000 plus 4 times y1, and y1 value here is 1000 divided by 16. Okay, so on further solving it, 4 so 1000 divided by 4 is 250 plus 1000, 1250 divided by 6. Yeah, we'll get around 208 point something. So here the option D is correct in this case. Yep, I hope it's clear. Feel free to ask if you have any doubt. Coming towards the next question, from here the 2 marks questions are starting. This question is from the linear algebra, from the eigenvalues eigenvector topic. We got a matrix A here, and we are supposed to calculate the determinant of characteristics equation, or equation here, that is minus a square plus 7a minus 3i. So whenever we are creating an equation in the form of a matrix A, we should first check whether that equation is same as characteristics equation or this similar to that. Okay, so let's try to create the characteristics equation of this matrix. Matrix A is there, which is 3 minus 3 minus 3 and 4. Characteristics equation is A minus lambda I, determinant equal to 0. So 3 minus lambda minus 3 minus 3, 4 minus lambda, determinant equal to 0. So in short, 3 minus lambda, 4 minus lambda, minus 9 equal to 0. And on further solving it, we'll get lambda square minus 7 lambda, and 4 multiplied by 3 is 12. 12 minus 9 is 3, plus 3 you will get. Okay, like this equation. And the given equation is minus of a square plus 7a minus 3i. Okay, so can we compare this? If you compare here, the only difference is the negative sign. So if I multiply this characteristic equation, that is equation number 1, by minus, so it will become minus lambda square plus 7 lambda minus 3 equal to 0. And yeah, according to Cayley-Hamilton's theorem, what we can do is we can replace lambda with the matrix A itself. Okay, because the theorem states that every matrix satisfies its own characteristics equation. So I can write it as minus a square plus 7a minus 3 times identity matrix has to be equal to 0. And now if we compare these two equations, we can say that our LHS is same. It means the value of this equation has to be 0. Hence, option A is correct in this case. I hope it's clear. We have just created the characteristic equation, applied the Cayley-Hamilton's theorem, and compared it with the question. Coming towards next question. Yeah, this question is from the Fourier series topic. We got a periodic function f of x, which is having two different values, f of x equal to minus 2 for the values of x from minus pi to 0, and from 0 to pi the value of the function is 2. From and the time period is 2 pi here. Okay, and using the Fourier series, we have to okay, screen is not updated. Let me just, yeah, I hope you'll be able to see it now. Yeah, so yeah, I'll repeat. This question is from the Fourier series, and it's a periodic function. The value of the functions are minus 2 for the interval minus pi to 0, and from 0 to pi the value of function is 2. And we have to tell that this series converges to by using a Fourier series. What is Fourier series? Definition of the Fourier series, or the form of the Fourier series. Can we apply it directly, or do we have to do some adjustment here? So you know, any function f of x, any periodic function f of x, we can write in the form of sine and cosine with a Fourier series, and which is like this: a naught by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to infinity 1 to infinity bn sine of nx. Okay, for this minus pi to plus pi interval. Okay, now we have to check what are the values of a naught, a1, sorry, a naught, an, and bn in this case. Starting with a naught. And once we calculate all these values, we have to put this in equation number 1. Okay, let's start with the a naught value. A naught is 1 upon pi. The formula here is 1 upon pi. General formula is 1 upon pi. Integration minus pi to plus pi. F of x dx. Okay, and as we have here interval which is in split, the function which is in split form, that is minus pi to 0 and 0 to pi, we have to add it. So how it will look like is 1 upon pi bracket integration minus pi to 0 f of x dx, which is minus 2 dx plus 0 to pi 2 dx. Okay, yeah, once we solve it, we'll get the value 0 because here this minus 2 pi and plus 2 pi will get cancelled out. So let's see how. 1 upon pi as it is, integration of minus 2 is minus 2x. So minus 2 into, after putting the limit, you'll get 0 minus of minus pi. So it will be plus pi and plus 2 times integration with respect to dx is x. And after putting the limit, it will be pi minus 0. Okay. So it is minus 2 pi here and here plus 2 pi here. It will get cancelled out and we'll get 0 value. So here a naught is 0. Let's try to find out an. 1 upon pi minus pi to plus pi f of x cos of nx dx is the formula for calculating the an value. Okay, let me stop sharing the screen and share it again. I hope you will be able to see it now. So a naught value we got as 0, starting with the an. Let's try to solve the an. An is 1 upon pi minus pi to pi integration f of x cos of nx dx. Here, if you solve 1 upon pi integration minus pi to 0 minus 2 as it is, we have to put. Okay, we will keep it as it is, and cos of nx dx plus 0 to pi 2 times cos of nx dx. Okay, and now 1 upon pi again as it is. So let's integrate it. Minus 2 as it is. Integration of cos of nx is sine of nx divided by n. Okay, limit is minus pi to 0 plus 2 times sine of nx by n. Limit is 0 to pi. Okay, we know that sine 0 is 0 and sine of n pi is also 0. Okay, so ultimately an value is also 0 because Sine 0 is 0 and sine of n pi is also 0. So a0 and an is 0. So in equation number 1, we have to forget the first two terms because we got the values as 0. So only the third part of the series is remain. That is in the form of bn. So let's try to find out bn here. Bn is 1 upon pi integration minus pi to pi f of x sine of nx dx. So in this case 1 upon pi bracket integration minus pi to 0 minus 2 sine of nx, okay, dx plus 0 to pi 2 sine of nx dx. Okay, and now let's simplify this. 1 upon pi minus 2 as it is. Integration of sine nx is cos of nx divided by n. Putting the limit minus pi to 0 plus 2 as it is. Integration of sine is minus cos. So here in the first term we have to make it as plus 2 cos of nx divided by n. Limit is minus pi to 0. And then second term integration of sin x minus cos nx. So divided by n. So it minus I have to write here, and here we can write as cos of nx divided by n. Okay? And the limit is 0 to pi. Now, if you further solve it, 2 we can take it out. So 2 by n also we can take out. 2 by n pi. And now if you put the value of x, cos 0 is 1 minus sine of then cos 0 is 0, cos 0 is 1, and cos of minus n pi is cos of n pi, and we can write it as minus 1 raised to the power n. Okay, so this bracket is for the first term. For the second term, again same, cos n pi is minus 1 raised to the power n. We can write, depending on the value of n, we have different values of cos, either minus 1 or plus 1, and cos 0 is minus 1. So if you further simplify it, what we'll get is 2 by n pi 2 into minus 1 raised to the power n, because 1, if this minus sign goes here, it will become minus, this will become plus. Okay, so 1 plus 1 is 2, and minus 2 times minus 1 raised to the power n. So I can take 2 common again, and I'll write it as 4 divided by n pi 1 minus 1 raised to the power n. Okay, so this is a simplified form of it. So we got bn here. Now it's time to combine this bn with the Fourier series. Okay, and how it will look like is f of x, we can write it as now summation n equal to 1 to infinity bn cos of nx. So bn is 4 by n pi 1 minus of 1 raised to the power n cos of nx. Okay, yeah, now let's complete the series starting with n equal to 1. So 4 by pi we can take it out basically, and inside the bracket what we can put is 1 minus 1 raised to the power n cos of nx divided by n. So starting with n equal to 1, whenever n is equal to 1, what will happen? Minus 1 raised to the power 1 is minus 1. So 1 minus of minus 1 is 1 plus 1, which is 2. So it is 2 cos of x divided by 1, right? Plus second term will become 0 because n will be 2. Minus 1 square is plus 1, and plus 1 minus 1 will get cancelled out. Third term, when n equal to 3, 2 times cos of 3x by 3. Fourth term will be 0. Fifth term, 2 times cos of phi x. 2 times cos of phi x divided by phi u. And here we'll get an alternate 0 and non-zero terms. Now, let's put the values of theta here. Okay. Yeah. So this is how, or plus so on, you can say. This is our f of x. Let's take any random value of x. For 0 to pi, the value is 2. So if I take any value of x, let's say pi by 2, the value of the function has to be 2. So let's put x equal to pi by 2. At x is equal to pi by 2, the value of function is, we know it should be 2, right? So let's write it as 2 is equal to, if I take 2 common from all the terms, it will become 8 by pi, right? And what is remain inside is yeah okay, sorry, yeah, I think we have done small mistake here. It is not cos, it is sine. Okay, sine of n x, and here I'll just replace cos with sine. Yeah, because I have written the series in the beginning. Yeah, here you have to multiply with the sine. You have to multiply sine to the pn. Okay, so coming back here, yes, at x equal to pi by 2, sine 90 degree is 1. So first term is 1, second term will anyway 0. I'll keep it as it is. Sine of 3 pi. Sorry, sine of 3 into x. So 3 pi by 2. What is sine 3 pi by 2? So this is sine pi by 2. Sine 3 pi by 2 is this. Then sine 5 pi by 2 is this. Okay. So sine 3 pi by 2 is minus 1. So minus 1 by 3. Okay. Plus 0. Plus sine of 5 pi is plus 1. 1 upon 5. Okay. And so on. So the series will look like this, something like this. Alternate plus minus signs you will get here. So now, if I bring this pi and 8 to the left hand side, 2 pi by 8 I'll get. So I can write it as 1 minus 1 upon 3 plus 1 upon 5 minus so on. Next term will be 1 upon 7 minus 1 upon 7 and so on is equal to what? 2 pi by 8. 2 pi by 8 means pi by 4. So you can say that this series is converging to the pi by 4. Okay, hence pi by 4 is the correct answer in this case. And you can clearly see the same value of the series we are getting, 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, right? I hope it is clear to you all. This is a bit lengthy question, but if you focus it and try to understand it, let's say you can clearly identify a and n, a naught is 0. Okay, so you can skip those steps and directly start working on the bn here, because looking into the limit and the functions are constant with the negative sign, you can imagine that they'll going to cancel and you'll get 0. Also, even after multiplying this function with cos, nothing will change, because cos of minus x is equal to minus cos x. Cos is an even function, so you should be getting same result. So an is again 0, but bn is not the bn is different. Bn is non-zero in this case, and that is 1. That is what we have to calculate first, and then just putting into the Fourier series will give you the answer. I hope it is clear to you all. Coming towards next question. Yeah, this question is from the integral. So let this gamma be the boundary of a closed circular region A, which is bounded by curve. So this is the circular curve, which is closed circular curve. Let me just draw it again. Yeah. Okay. And so this is a circle with a radius 1. So all the points on lying on this curve has value of r or radius equal to 1. Okay, x square plus y square equal to 1 is the equation of the circle. Okay, circle with radius r. So if you trace any point on this gamma closed curve, the value of r equal to 1. Then we have to calculate the integral integration over this closed curve 3x cube minus 9x y square ds. Okay, where ds means the integration along the bounding curve. So we know that this is a circular curve, and we can convert this line integral basically in the polar form. Okay, so I can write it as integration 0 to 2 pi, replacing x equal to r cos of theta and y equal to r sin theta, where r is 1 in this case. You can write it as 3 cos of cube theta minus 9 cos of theta sin square theta d theta. So I'm just replacing x with cos theta and y with the sin theta. And now if you solve this, what we will get is 0 to 2 pi 3 times cos cube theta can be written as cos square theta into cos theta. And what is cos square theta? It is 1 minus sin square theta. So 1 minus sin square theta into cos of theta minus 9 cos of theta sin square theta d theta. Okay, and if you further solve it, integration 0 to 2 pi 3 cos theta minus 3 cos of theta sin square theta minus 9 cos of theta sin square theta. So it will become 12, total 12 cos of theta sin square theta d theta. Okay, and now if we integrate with respect to theta, we know here for the first integral it is very straightforward. That is integration of cos theta is sin theta, so 3 as it is. So 3 times sin of theta, putting the limit 0 to 2 pi minus 12 as it is. Integration of cos theta sin square theta, you can do the substitution here, and you will easily get here it as, I would write it as 4 sin square theta. Why I am writing 4 sin square theta? Let me explain you here. What is put the limit basically here 0 to 2 pi. So if you differentiate it 2 sin square theta, you will be getting the same term. Okay, to no, it's a 2 sin cube theta, sorry, yes. And now let's differentiate this term. What will happen? 4 into sin cube theta. If you differentiate it, what you will get? 4 as it is. Differentiation of sin cube theta is 3 sin square theta, and differentiation of sin theta is cos of theta. So 4 multiplied by 3 is 12 sin square theta cos theta. So that is what we have here on the left hand side. So you can say integration of this 12 sin square theta cos theta is 4 sin cube theta. And if you put 0 to 2 pi limit, we know sin 0 is 0 and sin of 2 pi is also 0. So ultimately you are going to get 0. Hence answer here is D, that is 0. I hope it is clear to you all. Okay, coming towards the next question. This is an boundary value problem, basically a differential equation problem. Let's try to solve this. I can rewrite the given differential equation as 9d square plus 1 times u equal to 5x. This is a non-homogeneous differential equation because we have one function on the right hand side, and whenever we have non-homogeneous differential equation, complete solution will be CF plus PI. So let's start calculating CF first. 9d square plus 1 equal to 0. You have to treat it as an algebraic equation. So d square equal to 1 upon 9. D will be equal to plus or minus 1 by 3. Okay. So the CF part here is C1 e to the power 1 by 3. Sorry, 1 by 3x. So you can write it as x by 3. And plus C2 e to the power minus x by 3. Okay. So this is the CF. Comparing the option, you can see that either option A or option B is correct depending on the value of C1 and C2, because we have similar terms there, e to the power minus x by 3 and e to the power plus x by 3. So let's try to calculate now PI here, and then we'll calculate the constants. In order to calculate the PI, what we have to do is PI is equal to 5x or 1 upon minus 9d square plus 1 operating on 5x. Okay, so I can write it as 1 minus 9d square operating on 5x. Okay, so 5x as it is, and if you do double differentiate 5x, will become you'll get 0. So the answer here is 5x itself. So the total solution can be written as C1 e to the power x by 3 plus C2 e to the power minus x by 3 plus 5x. Okay, they have given the initial condition u of 0 equal to 0. So u of 0 equal to 0. So 0 will be equal to C1 e to the power x by 3 or e to the power 0 by 3. E to the power 0 means 1 plus C2 e to the power again 0 by 3. So again 1 plus 5 into 0, which is 0. So from this equation, what we'll get is C1 is equal to minus C2. So the signs of two constants or the coefficients of e to the power minus x by 3 and e to the power x by 3 are different. So the only option which satisfies that is option A. Okay, hence option A is correct in this case, because here the coefficients of both e to the power x by 3 and e to the power minus x by 3 are positive, which is not the case. Okay, because C1 is equal to minus C2, and that is the reason we are choosing option A here. I hope it's clear. If you want to calculate the value of C1 and C2, what we can do is we can again differentiate this du by dx and equate it to 0. This condition will give you again one equation in between C1 and C2. Solve it with respect to this and you will get the values of C1 and C2. But that is not needed in this question, because just by looking into the option, we can judge the answer. Okay, we got one question here from Anish. Could you please repeat the second step for PI? Okay. So yes, yeah, I have to write it as a -1 here. Yes, thanks, Anish. It is 1 minus 9d square raised to the power -1. Okay. So what is this basically? It is a series again, right? So 1 minus 9d square plus so on. Okay, and that 1 plus 9d square plus so on, and that you have to operate on phi x. You don't have to consider the all terms because the second differentiation of phi x itself is 0, so you don't have to worry about the upcoming terms. So that is the reason I have directly written it as like this. Okay, so just to let you know, 1 minus x raised to power minus 1 is equal to 1 plus x square plus x raised to power 3, so on. Some formula is there, right? Series. So that is what we are using here. Is it clear? Yeah. Coming towards the next question. Yeah, this question is from the Laplace transform. Dou to u by dou t square. Okay, in simple words, you can write it as u double dash plus 2u dash plus u equal to 1. This is a differential equation. They have given the initial conditions. U of 0 is 0. And u dash of 0 is also, sorry, is 5. This is given. And we have to find the Laplace transform of u of t. So yeah, whenever we are solving the differential equation with the Laplace transform, you have to take the Laplace transform on both the sides. So Laplace transform on left hand side is equal to Laplace transform on right hand side. So Laplace transform on left hand side is u double dash is s square f of s minus s f of 0 minus f dash of 0 plus 2 times s f of s minus f of 0 plus Laplace transform of u is f of s. Okay, for example, or you can say a bar of s rather. Okay, a bar of s is equal to yeah, Laplace transform of 1 is 1 upon s. So now apply the initial conditions which they have given. F of 0 is 0, so basically this term will become 0. This term will also become 0. F dash, or you can say u dash of 0 is phi u. So I have to write this term as phi u. Okay. And now if you take the terms which are the coefficients of, let's say, yeah, coefficients of f bar of s, what we'll get is f bar of s into s square plus 2s plus 1. Okay, s square plus 2s plus 1 we are getting here, and minus phi s, sorry, minus phi also you are getting here, and that is equal to 1 upon s. And this minus phi we can bring it to the right hand side. It will become plus phi u, and you can also write it as 1 plus phi of s divided by s. Okay, and you can write it as f bar of s as 1 plus phi s divided by s into s square plus 2s plus 1 is s plus 1 whole square. Now if you compare the options, yeah, we can see option B is correct in this case. Phi s plus 1 divided by s into s plus 1 whole square. Okay, I hope you understood the problem here. Any doubt in this case? Okay, so if no doubt, then um, yeah, that's all we have here from the GATE 2014 paper. Yeah, thank you all for joining this session. If you have any doubt, feel free to ask. Otherwise, we'll end the session. Yeah, okay. If no doubts, then thank you all for joining this class, and bye.